Now let's talk about the other type of weathering, chemical weathering, here in video lecture 7.3. Growing up in a chemical science class, you might have come across something called hydrochloric acid. If you don't know what that is, Google it right now. But a hydrochloric acid, the idea here is you drop a little bit of this hydrochloric acid on certain objects. What will happen is that hydrochloric acid eats away at that object. So this would be one of maybe the experiments you would have conducted in chemical science class in middle school. But one of the characteristics we have with chemical weathering, it slowly eats away at the underlying rock. And so we have these original minerals that we've talked about, these original rock minerals, and what happens is over time they're altered. They're not broken down in terms of physical weathering processes. Instead, there's a chemical, there's some substance that is eating away and going to cause weathering to occur. And so what happens here is you have a slightly acidic compound. We'll go through some various examples, in particular working back with that limestone we talked about in video lecture 6. And we got some examples, but the main idea here is over time, chemical weathering processes, they soften, they weaken, they break down, and they essentially round down underlying rocks. And so physical weathering associated typically with sharp angular fragments as far as their what they break down. Here we're going to see more of a rounding down as far as our various rock objects. There's two examples, hydrolysis and oxidation. We're not really going to talk too much about here in G107 because essentially these are things that don't occur as much here. But the basic idea with hydrolysis is you have water plus another substance equals a new compound, and it's typically clays that are produced. So here we have water plus another substance that creates that. Oxidation, we can relate to that if you ever think about rusting of a car or a rusting of a grill, an object. What simply happens there is you've got dissolved oxygen and water plus the metallic components of a rock or a grill, what have you. One of the things is over time that dissolved oxygen plus iron creates rusting. So here we have the alterations of various things due to chemical weathering processes. But the one we're going to really focus in on and one we're going to examine you on is carbonation. The key to understanding carbonation is just essentially the word itself. The word carbon is in carbonation. So the key idea here is reactions occur when carbon combines with minerals and then dissolves them, breaks them down. This is also referred to as solution or dissolution, this process. And key to understanding this is carbonic acid. Where are we going to find carbonic acid? Well, essentially carbon, it's all over our atmosphere. How do we know this? CO2. The whole C in CO2, that's carbon. Further, there's carbon in our soils. There's carbon in our ground. So one of the things is, well, where are we going to get water? It's going to mix with carbon to create a slightly acidic compound. Where we're going to find that? Rainwater. And so rainwater picks up CO2, picks up carbon from the atmosphere as the rain falls down from the sky, but also as it works through the zone of aeration, it slowly infiltrates and percolates into the ground, and what we have is a slightly acidic compound now created from that carbon plus water. And so this is the key to understanding carbonation, is the fact, first off, that carbon dissolves in water, and then eventually rainwater picks up that CO2, or essentially provides that water, and then it's going to slowly soften and break down a rock that's susceptible, a rock that is capable of being chemically weathered, a soft rock essentially. Not all rocks are going to be broken down chemically, and so it requires certain types of rocks, as we'll showcase here on a following discussion.